last class had some questions about the homework, although they're not the same as this one, so I figured that's all I would do today. So are there any questions about a specific one first? If not, I may just breeze through them all except those 10 and 11, which actually are not really, and I think, no, yeah, just 10 and 11. Huh? Sure, I can go through 10. Okay. On 10, let's see. Oh, it launched another window. Okay. Wait a minute. Okay, wait a minute.
You never finished it.
Let me stop for a second.
The one from the girl to the home. He started it.
But it says it's a tutorial.
I did it, but
Okay. Wait a minute. Okay, well, wait a minute. Okay. Okay. So am I clicking the right one? Which one is it? Okay, so. Oh, okay. I did not know that was considered a tutorial. Wait a minute. I don't get that. Wait a minute. Okay. I did complete that one though. Did I not? What are you having trouble with there? Actually, I kind of think we did, but I can do it again if you want me to. So, okay. So it's so the last part you're looking for the. Okay, so let me move down because I think I rushed through that. It happened very quickly. Okay, wait a minute. The displacement of the boy relative to the tree. Now, wait a minute. That was A. Okay, relative to the girl. So basically, you're looking to add to, and he gives you the vector diagram. So I'll do it in a compact way. I don't know that I can do it without doing A first. So, I mean, if you look at, I think you just call them D1 and D2, and then D3. I mean, all you're doing is you're finding, I'll call that D0 is equal to D1 plus D2, and D1, okay, so if you look at D1, it's nothing more than, I can line these up. D1 would be brother traveled 24 and theta, so I'll collapse that. That's the angle between there. So it'll be cosine 25, not 22, but 25i plus the other. And then D2 would be, if you basically set yourself up a new x and y coordinate, you use this as the base. You just add this vector, or you're basically bringing it back here and finding its location, adding it, which would be, D2 would be 11. Cosine of the angle that collapses it to the x is 135 plus 11 sine of 135. That gets you your D0. Now, if you look at his drawing, we might as well do D3 as well, because you got to have it. D3 is 18.5. Now, is it measured with respect to that? No, it's measured this way. So, another thing you could do, what is that? Well, I guess if you used it as a minus 114, 360 minus 114, we'll play with that for a minute. And here, I'll just go ahead and do that. Turn the calculator sideways. Let's see, so if you do 114 and do a cosine, I'm just going to play with for a minute. Cosine minus 114 is going to be equal to minus 0.4067, just out of curiosity. Sine minus 0.9135 makes sense because the vector has to be going in the negative x and negative y direction. But if I take 360, take off 114, that's 246. So cosine 246, guess what? Minus 0.4067 sine 246. It's the nature of these things, minus 0.9135. So they're both the same thing. So before I start saying anything about any particular one, I'm going to project it back using this angle just because that's the way but you can project it back the other way, you'll get the same thing. So cosine 246i, 18.5 sine 246j. Now, if you got a vector, let me draw them a little smaller here, because I'm going to scroll the page up. And I'm going to make them a little bit more so the tips can go away. So if you're looking for this vector, I'll say DD. If this is the origin, and you just say, well, D1 plus D2 plus DD is equal to D3. So if you're looking for that one, you could leave it over there and say D, the difference between them, is D3 minus D1 minus D1. Now, I did it by components. You can spend the time and do it the other way. That's okay. If you want to do that, I think we can look back. I can show you how I did it last time. But as a matter of fact, let's just go take a quick buzz back and let's see if I can find that. Because at least you know. Let's see. That is me. Okay, so let's see. My videos. It's moving kind of slow. These were live. That should be right now. One of these got messed up as far as the title, I think. Yeah, that one. I could fix it right now, but wait a minute. That probably is not. Let's just launch. I'm pretty sure it's not that one. It's probably that one. Oh, wait, what happened there? Okay. So did that have the picture there? Let's just roll it through. Oh, yeah, there we go. So, ooh, it's way out of focus there. D so tree to boy, and then this, you're going to get, basically, you'll see. Okay, what's 90 minus, was it 114? 114, so that's 24, right? So I'm going to do this. That's the other vector, which actually I think I found
Okay,
it
this is
both
just the
ways.
way I do things.
But I tell
Okay,
you
it's
what,
24.
I'll do it again.
If I want to project that
We'll
back
look
to
back
here,
at that as a reference.
that's just
I'll
going to
sort
be
of hold on to it.
cosine
So in
24.
fact, let
But
me see.
that's in the minus
It's very near the end. Maybe.
40.92.
Okay, so if I pause it right there. So it's kind of hard to see, but you'll see this. So if you want to do it by components, you'll see that that video has it so that these are the components. So what I'll do is I'll use this information, make it go away, then I'll redo it and you can see it again. But you'll have two actual lectures there. Oops. Okay, I need back my, is it this one? Yeah, I need this one back. So if I just go over and use MATLAB and use this and this and this, as for my vectors, you'll see things can go rather quickly. Okay, hang on. Okay. It might be having trouble communicating with the library or something. Okay, there we go. So I can just look up here, let's say. I call this D1. I'll call it just D1 is equal to, and I'll do it in the two components. So D1 is 24 times, tell you what, I'm going to put the bracket over, 24 times cosine degree of 25, and then I'll say sine degree of 25. And so there's your D1. It's 21 feet, or is it, no, I'm sorry, 21 meters, 10 meters. And if you put in D2, it's equal to 11 meters times cosine degree of, it's at 135, and then space, sine degree of 135, and then you'll get that. Now, that's the one we had before. It went to the right 7 meters, went to the left 7 meters and up 7 meters. Let me move this over here so you can see it a little bit better with the picture. And so it's basically you move back 7 meters and up 7 meters. 45 degrees, because 135 minus 90 gives you 45, so that's why they're equal. The other one is you move to the right 21 meters and you move up 10 meters, roughly, a little bit, plus some digits. If you look at D3, this is the last one, is, and let me shrink it down. Look at D3, it's 18.5 times cosine degree of that angle. Now I can use the minus 114. I'll just go ahead and use the minus 114 now, because I can see it off the page. And you end up with D3, which is that's moving to the left 7.5 meters and down almost 17 meters. So if you want to, you can find, for example, the norm of D1 plus D2. And you'll see 22.7247 right there. If you look back, okay, I have trouble finding my mouse in this thing. if you look back at, okay, I was there. Okay, there it is. If you look back at the video, that was the 22. Okay, let me see if I can. So there's your, okay, so we did it. If you look back at this video, you'll see we did it by the component thing. And you'll find this distance is 22.72. That's off of the other lecture. This time we're doing pure components. Last time we did, I have to hit this in order to get back to, wait, where is it? It's not there. It's not that one. It's not that one. That's the one where we're at. Is there another one? Wait a minute. Where did the book go? Okay, what did it launch another window? Oh, I guess it is. There's another window down there. Okay. So if you do that and look at MATLAB, that's what it should be doing. You'll see the 22.73. So you'll see we got that last time. This time we did it by components. If you want to go through and do this, because now I have D3 in there, the D distance between this point and this, we'll look at that, you know, D3 minus D1 minus D2. That's what that should have said. That should have said a 2. So let's look at the D3, or the D distance between them. I'll call it D with a little d is equal to, now the equation you see up there, it's the bottom right of the board, which it's too far for me to see. D3 minus D1 minus D2. I interchanged the 1 and 2, but that should be okay. So I get this vector. So if you think about it, this means minus 21.5 meters. This person, 21.5 meters, and then minus 34, or actually just going, you're going left and then down, 34 point something. I can't really read that here. Is that 8? Okay, that's hard for me to read that. And so if you want to know the distance there, all you do, I called it D little d. So you can do the norm of D little d, and you get, I think that says 40.92. Okay, so, all right, so give me a second. Where, it was under that, it was there. Okay. So I got to there. Now maybe I didn't complete that last part, but I thought I did. Okay. I have to take back. I don't know that I did, but I could have swore. Oh, okay. Well, there's the 40.92. So I must have done something because I took the norm. Yeah, so I took the, did you mean, okay, so I must have made a mistake, and then I must have done something weird, typed it back in, 40.92 there, and it's 40.92 there. So I guess I did, I guess it happened so quickly that I may have been running out of time there. And so, okay, so there's where, okay, so if you look at me, that's where I'm at. It may be hard to see. Let me drop the screen. If you look back, okay, so it might have been, you have to watch that real close because I think I did it fairly quickly near the end. And so you see the 22 right here and this angle between it, and you see that in the cosine of the angle between it. Because I think we did do that. We figured out that angle and we went back to it. So here we did it with the things. We end up with the answer, and I think I actually went back and found it the other way as well. I'm not sure. You have to watch that. I mean, but I don't know if I made much of sense there, but here, let's see if I can go back to engineering and then go back to here. So essentially, now the board material's gone. So this way, I just went in and I did vector. You know, I just basically I added that to get this one. So I mean, I can replace these two vector additions with this one, which is I think what I did. Here I just laid them out. I went from here to here to here, back to here. So first step, second step. So this is leaving the tree, going to somewhere else, going to find the girl, which is here, which has to be the same as where the girl left from here to here. Then I just rearrange the equation, and that is the distance from here to there. So I just subtracted, I laid out these three vectors, subtracted them, and then found the distance between them. Now the angle between them with respect to the east with the counterclockwise, you could do that by, I'd have to take my components, which would be, okay, hang on, 21.49, 34.82. So this is the vector. And if he wants the angle counterclockwise with respect to east, or the x-axis, then one of the things you could do is just find this and add 180. So you could take the tangent of that, which is equal to, okay, so you gotta think about that. I always look at it like this. I'll use this term for a moment, the h for hypotenuse, but I usually don't really do that. So the sine of the theta over the cosine of the theta is equal to the sine will be this 34.82 over h, and then the cosine would be the 21.49 over the h, which would be the same thing as the tangent of that. So if you want to do the, okay, it depends on whether you like arctangent or tangent inverse. 34.82 over 21.49, but then you got to add 180 to that, and that's, I think, the angle that he's looking for, if I'm reading that right. The angle is given with respect to the east. So, okay, I'll buy into that, with the counterclockwise being defined as positive. So, well, I guess the other thing too is if you found that, you could come up with that one or this one, both of those. This would be a minus number. This would be a plus number. So there really is two answers there. For that matter, there's an infinite number of answers, but I don't know. So yeah, because if this is defined as positive, then you could come up with a negative number, or likewise. I mean, I don't know what he did as far as coming up with one. That would be an interesting question. What does he come up with? Okay, so he has 40. Okay. So 40.9, that's what we ended up with. think we ended up with 40.92. Oh, that's really weird. He puts a comma right there. 238. That's really weird. Okay, and then the angle being 40.9, or either that or the minus 122. So that's a little strange too. Also accepted is that and that. So that's a little strange. So I guess on their end, they would have to write the software to accept either one. I'm guessing that they have that done. So I don't know, did I answer it, or I didn't answer it? Oh, now the numbers might be different.
Not the numbers, like the angle, like, your triangle is like one below.
Like that? Like this one? Here, let me get that all off there for a minute. So, what part? Okay, so, but your drawing looks like that, right?
My first one does, but then there's a figure 3, that's the board and drill.
That's down a little bit.
Yeah.
Okay.
Is that the one to the home? Just
Not that one, but that one.
that one. Okay, let's see. We found an angle of the board and tree, right?
From here to here.
Yes.
Well, yeah, I think I did the other day, but I don't think I did right now. I don't have that one, but I could find that one. But yeah, I could find that.
Okay, see, that's what I was trying to put in, that in my 114, I think
Uh-huh.
114, and find that interior angle right there.
Oh, this right here.
Yes, so I can find the hypotenuse.
Okay, to find that distance.
That interior angle equals 186. That's what the angle inside of triangle can't be more than 180.
Well, now that's an interesting question. Let's approach it from that way. So what we'll do is we'll first try to find that one. So with that, I don't need this. I can just, I hate to mix the problem, but I'll go ahead and mix it. So D1 and D2 would give me a vector up here, and I could find that real quick on MATLAB, and then I'll look for the angle, if you don't mind. So give me a second. I got to get to the MATLAB. So I already have D1 and I have D2. So I'll say just, I don't know, I'll call it Q because I don't know what else to call it. Q equals to D1 plus D2. So I got this vector that looks like that. So it's 13.97. Okay, 13.97. And it comes up, and I'm sorry my drawing, 17.92. Okay, that's a weird look. It's kind of doesn't look like it's to scale. But then I could do that. Okay, the tangent inverse of, okay, so that's the issue sometimes I have, is that which one is the, okay, so if you do sine of theta, this is this one over that one, right? And 7 equals to, and let me see if I can figure out what that is. And I have to put in D for degrees, and, okay, was it 13.97? No, it was 17 over the other one. I could have just copied. Wait. And so 52.05, is that what you ended up with?
I got 59.
Okay, so you oh, did yours have any different numbers than this?
They were a little bit, but
Oh,
not much.
oh, okay. Well, I'm gonna go ahead and use mine, because ours are kind of close. 52.05. So then, then the thing is, you're looking for this angle. That's what you were going after? Okay.
The other angle, 114.
Okay, so the other one, this was minus 114, right?
So I just added 114 plus 52, and then I subtracted that.
Okay. Okay, so this angle, which I'll call, for lack of a better thing, I'll call it a little c. 360 minus, so I got all those together, 360 minus 114 minus 52.05, and here. Minus 4 minus 52.0561. 193.94.
That's what I was getting stuck at, just having that angle being triangle.
So what he's doing, okay, so if it's doing that, okay, so what he's doing is folding the triangle over. Oh, here. So what he's drawn and what's actually happening is not the same thing. So if it is that, then this point draws over to that side, or these 2 points go over to here.
That's what I thought the triangle was.
Yeah. So the drawing is, it needs to be flipped, but unfortunately, for me, I'll try to redraw it. So it's like that.
So I should use that 114 plus 52 for my interior angle on that.
Yeah, 114, 52. Oh, well, wait a minute. No, because you already figured that out. So it'll, well, if you flip it, what is 114 and 52? What is that?
It's 166.
166. 166 and, okay, about 166.
Yeah.
Okay. Yeah, so if you do that and it flips over, then that just tells you, okay, I've already lost track of my numbers. Okay, this was 193, and this was, what did we just say? 166. And then, so he's really messed with you. So then you got this distance, which I think was 22. And you got that distance, which was 8. Oh, you're,
Yeah, yours probably was that. Mine was 19.
oh, okay. So mine was that. And so now you can do the cosine, law of cosine.
Yeah, that's what I tried doing, but I think I got it wrong because I used that 193.
Oh,
166.
oh, okay, okay.
That's what was confusing me.
Yeah, I mean,
Let me try that again.
yeah, the thing about it is when you do a drawing, and then this could be real problematic. So when you do a drawing that remains fixed, and then you give everybody different numbers, there's a chance you can fold over and your drawing doesn't match your numbers. Somebody else in the room, their numbers in the drawing match. So that kind of stinks, because in a way, one person can use the drawing and get it right, and the other person can use the same drawing, get it wrong, just because. For example, I mean, if I used, okay, think about it like this. I'm drawing D1 to D2. Okay, well, here's the drawing. So if I do D1 to D2, and D2 on one person's page is 15 instead of 11. Think about that. You moved 24, and this time you moved a larger distance, then that would put you into this triangle. The next person may get the problem and say they got 24 and 5. So what they did is they moved out 24, a very short distance, the other person, so their triangle got folded over. And so this is not an easy thing to manage. So, and I used to do, well, I guess it was just last semester I was doing the Moodle and doing this stuff and designing these. And after talking to the publisher, I decided to use their system because they had a lot more problems. It takes a lot of effort to make these problems this way, you know. And I kind of, there's just a state of opinion that I kind of think we've lost track of what we're doing in education, because what we've done, seems like to me what we're doing is we're removing people from the educational system and replacing it with bots. The problem with that is, what people don't realize is putting your pen to the paper and writing it on a sheet of paper is a lost art, in that it's very apparent to me that when you write it down in organized fashion, you organize your thoughts. If you're dealing with this computer stuff, I don't know, most places have TAs to grade everything, to do everything, and those teaching assistants help that grading process. We just don't have that. It requires funds in which those funds are going to pay for the systems instead of the people. So it's about time for me to retire out of it because of that. And that's what maybe sometimes they're wanting. I don't know. So this is a typical example of that, where it got flipped, and you have to kind of, but if you think about it, yeah. Did anybody else's get flipped that way? Did everybody's get flipped? Did anybody's not get flipped? So everybody got flipped.
His issue makes sense why I couldn't figure it out in triangles. I have a question doing it in components. Here. Huh? I did it with components finally, but first time I did it, I was trying to add the vectors for the boy resultant and the girl to get get them back together.
Yeah.
And I remember watching your lecture where I needed to subtract the boy vector from the girl to get the resultant vector, but I'm still having a conceptual error on that.
Oh, okay.
Because I thought it was vector addition.
Okay, so think about it like this. If you just walk the vectors, I mean, that's a common thing. You just walk the vectors here to here to here.
Yeah.
And then you stop, and then another person walks the vector to there. So all I'm doing is walking the vector D1, D2, DD, D1, D2, DD. And I end up at the same place as the person who walks the one vector.
Okay.
Does that make sense? So often, I mean, okay, so, I mean, I've heard people use that term, and walking the vectors, and that's kind of what you're doing. And you're kind of doing that in the three-dimensional thing, because you're walking each axis to get to a point.
So walking from the origin of the boy and then walking from the boy to the girl.
Yeah.
Equal to, in that case, the girl would be the result.
Right.
That's where I was screwing up. Like I said, and I remember seeing your lecture, and I redid the problem, subtracting it, and came up with the problem.
Yeah. Yeah, and it is. You have to stop and think about it, because it's that way too when the resultants. So sometimes you add two resultants. It's kind of weird. So you have, and you'll see it on the page. Okay, well here's F1 and here's F2, and I'm trying to add them. So at first point, you think about what you're doing, but then you're like, oh well, actually when I add them, I'm taking one and putting it at the end of the other. So if you put it at the end of the other, yeah, that's the resultant. But sometimes they just list them that and that, and you're thinking, okay, so that when you're walking the vectors like this, you have to think a little bit differently. Here you can just kind of drone through it. Well, F1 is equal to this I plus this J, and F2 is equal to this, I plus this J, and then you add these two numbers up and you get the F resultant, and everything's, everybody's happy. But then the other is, you take that vector and you erase it and put it right there. And so it takes a little getting used to. And so in a way, I guess that is one advantage of, and that's probably where the power of this problem actually came in, is it makes you think about how to walk through it, even if you're using components. So I say this is a better problem than I thought it was. I just thought it would be cool because it was very confusing. So I apologize about that. But actually, it may have been some value, you know. It may have been the hardest problem there. And yet what's so frustrating is you're looking at it and you're thinking, this is such an easy problem. And then it frustrates you. But, you know, that's just the way things are. Sometimes the easiest problems are the ones that trap you, you know.
So,
Uh-huh.
I'm trying to use the long signs. That's giving me like 30 degrees.
Oh, for one of these?
Yes.
I would imagine it probably would give you a very tiny one.
So, I mean, I don't understand how I'd get degrees then.
What do you mean?
The angle between it, so it was like 223 or whatever.
Oh, okay, so which one was 3 degrees? Was it this one or that one?
But yeah, from the
This one?
top one,
Okay, so this is the,
the other one.
wait, the other one,
Yeah,
3 degrees.
yeah.
Okay, so what's the other one then? Just out of curiosity.
Well,
A little bit larger than.
it's 4.
Oh, it's 4?
Yeah.
Oh, okay. Well, that's cool. So in essence, what, say, okay, so I lost, okay, so here we go. Wait, 4 and 3 and 166, is that 180?
No.
Oh.
Well, that's for mine. Mine's 173 from interior.
Oh, yours is 173. Okay.
Yeah.
Okay, so let's just use yours for a minute, and then we'll just, okay, so we're going to use yours for a minute. What was yours? Yeah, they're slightly generated differently. Just to mess with you.
So that you can't cheat off one another.
Yeah. Makes it a little bit, yeah. So what was yours? 170?
Yeah, 173.
173. Ooh, 173. And then this one was 3, and this one was 4? Okay, so this is the person, the boy walking this direction. So the question was, or wasn't it that they wanted that? Did they want that one? I guess
That's
I.
why I'm getting confused because I was trying to do long signs and stuff.
Well, the lost signs will give you that angle, and then what you could do here. Let's move this up out of the way because I can't see the. Okay, using the method. Okay, determine the deflation of the boy to the girl. Okay, wait a minute. If this is part B, right?
Yeah.
Enter the angle measured counterclockwise from the positive x-axis. Isn't that interesting? This time he used the positive x-axis. The other time he said east direction. So it's the same thing. So then the other question is, what's that angle? Did you find that one? Yeah. Okay. So if you do 180 plus the 3 plus the question mark, what was the answer that you got that it showed on yours? For the answer, does it show you the answer, or does it not? Oh, it doesn't.
Until you ask.
Yeah, say you showed us when you were walking through it.
Oh,
That's
oh,
what you got was like 223 for your.
oh, okay. Well, so okay, so if you want to find this one, that angle, in other words, okay, so yours is 173. Do you know the distance
Mine was 21.2.
from here to here?
Yes, sir.
21.2. So this is, okay, I got so many. I tell you what, let me take the angles and put them all on the inside. 177, 21.2. Now, okay, so I'll use this drawing. Okay, so this is kind of weird. I'm trying to kind of arrange my brain around it. D1 and D2, because I had this picture before and I have this picture now. So, okay, so this is from here D1, D2, gets me here. So your drawing, and as well, it seems like everybody's drawing, is actually this. And that gets you there. And the girl did like this. So in fact, this is what you end up with. So the problem is, okay, when you look at this, you got this. So that can be very annoying. Now components, it's really easy, but if you're going to do angles, you got to come up with that extra. If you want to do components, then it's pretty easy because okay, I can do mine, but I don't have your numbers. But in mine, I end up with the DD, and then I can take the tangent of one angle or one distance over the other and get the answer. Oh, okay, now, okay. So, okay, let's try that. Let's do that for a second. Okay, so I'm going to take my DD, and the DD is just going to be this. Okay. Let me go back to mine. I'll use my numbers if that's okay. I still should have DD in there, shouldn't I? Didn't I call it DD? Okay, minus 21. So that's what I got there, and then 34. So, okay. So, 21.49 and 34.82. Now, if I take the tangent, now you said you got 27? Okay, so if you got 27, okay. So now mine won't be 27, but I'll put mine in. 27.5 and then plus 180 would get you that angle. So now let me do mine and see if I match mine. So our inverse tangent of, and this I always got to think about, it's the sine over the cosine. So it's the 34.82 over 21.49. Did I do that? I may have done that. Okay. Okay, so it is, you know what? I can use the copy paste here. I'll do a copy and then a paste and a copy and then a paste. And then I get 58.31. Wow, I got it quite a bit different.
I know, that's what, if I do it how you did it, like cause I just put them up in like X values and Y values, and then I just use my Y value of 35. So, see, I got 62 that time.
Oh.
62.5.
Oh, you got 62.5? Okay, so let me add these two. I think for mine, I mean, it has an answer down here, so I'm going to go through here, but I'm going to add 180 to that. Plus 180, because I'm in degrees. 238. So if I scroll down, there's this 238 right there.
That's right. I said, whatever I use, the component form, it worked.
Oh, okay. Yeah, it's just, there's a lot of stuff on this page. I mean, there's a lot. Yeah. And it's good to go through that, I think, sometimes, to work your way through it. Because I think it formulates things in your brain that, if everything isn't very, how should I put it? If it's not pushing you, you may not be learning much. So sometimes the problems won't do anything to you. Now, why was this one called a tutorial problem? Did it have a video? Was there a video with this at all? Okay, I don't understand that. So I hope I was helpful. I mean, if you look at the video now for the lecture, it'll probably be quite confusing. But if you were here, hopefully it's less confusing. I don't know. Yeah, Well, I can see that now that you bring that up, and I'm like, wait a minute, that's not, yeah, so the whole thing is flipped over. You know, I probably should have drawn it in MATLAB and drawn the vectors, and we could have seen it, you know, but, oh, well, okay.
Because I guess it's the numbers for the answer that I got. And it says, so like I got 81.5 for one of my ranges, and then it turns out that it was like 85, and it still counted it correctly, so I'm kind of confused right now.
Well, it's probably like,
Hey, you guys are doing better than the, look at this. So check this out. So far, all the people that have taken the test, or this problem, 28, 65, 87 got it right, 2 unfinished, and that. So far, we only have 7 of us that completed it, 100%. And then wrong divided by student. I don't know what that means. Hence divided by student. I don't know what these mean.
per student and wrong per student.
Oh, so when you click the hint, I guess it counts it.
Yeah, so if you click the hint, it reduces your total grade, so it takes away points.
Does it really?
Yes.
Yeah.
Well, that stinks. Well, I didn't.
I used the hint on like one of the questions, and I have 0% points, so I got no points for that question, even though I got it correctly.
You know, if you do them, I'll adjust it. So if you need a hint, don't worry about it. I don't know that. Maybe I'll go back to the grade and see if there's a way I can make hints not count for anything. I would have. I mean, if I'd have seen that, I'd have been clicking the hints too. So I'll go back and see if I can.
Right now I'm at like 60%.
Oh no.
Number 10. Because I'm getting the points reduced.
Okay. I'll go back and see if there's a way. Now, I know that this is what it told me, is that like, say, 2 weeks from now, I go back and I adjust the homework so it says, okay, hints don't count. It'll go back and give you back the credit. So give me some, this is an adjustment for me too. So communicate those things to me. I'll go back and see if I can adjust things, and we'll all kind of figure this crazy system out together. So
Have a good one.
you too.
Excuse me, I'm gonna miss Monday.
Oh, okay.
Next week because I have a work conflict. We're in processing for outage and.
Oh, no.
Minimum number of people who can do a certain thing.
Yeah.
My time on deck to do it is.
So is the outage occur like after that? I mean,
Yeah, what we're doing is we're bringing in contractors right now.
Oh.
Because we like double our staff.
oh, okay.
Before we started outage.
Okay.
And since the staff comes in only, once a year, maybe twice a year, we have to go through the whole in-processing thing, get them their badges.
Oh.
Make sure their training's current, all their.
Oh, okay. Okay.
I've got some of the training part of that to do for them, so.
Okay. I'll try my best to not goof up the lecture so that the stream will be there.
I can keep up. I can
Okay.
no problems. A few lectures I've had to look at.
Okay.
No real problem.
And I'm going to be releasing the next homework sets over the weekend. I may release 2 or 3 at once.
I missed you releasing the quiz yesterday. I guess you did that Wednesday.
Yeah, now it's released, but you can't take it, I think, until this coming Wednesday, I think.
Oh, I thought it was due Monday. It's not due yet?
No, it should be due next Friday, and then next Friday and Saturday.
Never mind, I'm safe.
There you go. I think I will double check that and make sure. Okay.